think AI is all about complex algorithms and mathematical concepts? Well, let's challenge that. Hey, it's Jacob. Welcome to this new video. And today I want to talk about why you don't need any background in order to learn AI. So if you don't know anything about AI right now, you might be thinking that what you need is a PhD, right? That's what we hear when we hear about like how do you get started with AI? What do you do? Well, you need to get started with like getting a master's degree in computer science, and then you need to move to like know about data science, and then you need to keep working and get a PhD in that. And if that's what you think, then it might feel like it's super overwhelming, because how many years is that going to take if you want to do that and you want to just get better at AI? You need a PhD. It's just way too much, right? So another thing that you might be thinking is maybe you're thinking you need a lot of math, right? But the problem is, if you're not good at math and you've never been good at math, like you're gonna need to go back to whatever the thing that you haven't learned about and then keep learning about that. I mean, that might feel super frustrating, because just because you're not good at math, then you're not gonna be good at AI. You can't use AI, you can become better, you can create tools, you can create your own startup. That might be what you're thinking right now. Another thing that you might be thinking is maybe you feel like it's super inefficient and it's super theoretical to learn about AI, because you're going to need to learn about all of those weird little theoretical concepts before getting into actually moving towards something that is actually applicable and actually solving real world problems. So that's you, like you don't have a PhD, you don't have a mathematical background, you don't like to learn about theoretical nerdiness, then I have a good news, because you don't have to do any of that. In fact, if you already have a background in those areas, then I would challenge you to put that aside, because it's gonna slow you down. Now, before I explain how that works, if you want to learn about AI but you don't know how to get started, you can click on the link in the description. You'll get a free online course. It's a complete roadmap to get started with AI and create your own AI today. So this online course is packed with value. It's completely free. It's just to help people that want to get started but that are non-technical. All right, so now let's talk about PhDs, right? Why don't you need a PhD, and how is that going to slow you down? So let's clear that up, and let's talk about theoretical knowledge. All right, so let's emphasize that part because it's super important. So the main thing here is, if you have a PhD, that means that you worked on a theoretical problem that is related to science, right? What's the problem with that? The problem is it's not a real world problem, because usually things that are real world problems do not have a theoretical part of it that is interesting from an academical standpoint. So that means that it's not going to be helpful. In fact, the reason why it's going to be counterproductive, in my opinion, is that you're going to try to apply a theoretical thing to a practical problem, which usually doesn't work naturally, right? You're not going to encounter a problem that can be solved from a theoretical standpoint. You're going to need to solve it from a practical standpoint. And then what's going to end up happening, what I usually see is people with PhD, they try to kind of like add some type of, like artificially add that theoretical problem that nobody has and try to solve it that way. And they miss the mark on the actual problem that people have. So let's take an actual example, and let's talk about Facebook, for example, right? You have a product here that have been built by people, but do you think that those people were PhDs, for example? How much of an academical value do you think that this product has added, right? Like, do you think that it contributed to science to build Facebook? Or, well, I mean, not at all, right? Like, there is nothing there that is interesting from an academical standpoint. And yet, well, we know what Facebook is, right? It's a multi-billion company, right? So my point is this: when we are talking about solving real-world problems, that has nothing to do with learning about like weird theoretical nerdiness that nobody cares about, and it's not going to help when we are building an app to solve actual problems. It's just for science. When you're learning, when you get a PhD, it's about learning about science in order to move and contribute to science. But it's never something practical. In fact, what I've seen a lot is PhDs, when they actually want to solve real problems and then go to a company, well, they're very, let's say, very, they, a little bit depressed when they understand that this is not what it is about. Why? Because a company has to solve real problems because they have to make money. And the only way to make money is to, actually solve people's problem. And so that's why they end up not using any knowledge that they've acquired during their PhDs. It's extremely rare that that type of thing happen, right? So that's why, like, do not waste your time trying to think that you need a PhD in order to move forward, because you don't need that, and it's going to slow you down. If instead of learning a PhD, you do other more practical things, then it's going to be 10 times better. I'm going to explain to you what to do instead, but let's talk about the next part. And that next part is going to be about a mathematical background. So any type of math. So why don't you need to learn about math when you are learning about AI? I mean, that makes sense that people are going to think that, well, you need to learn how math works because, well, everything that is related to AI, under the hood, it's about math, right? Let's take an actual example of a neural network, right? So here, this is a neural network. So a neural network, basically, if you don't know what that is just something that trains based on data, right? You have a massive amount of data here, and it's going to learn by just training. So this is what we have, and in order to build something like that and apply it to an actual product, most people are going to think that, well, you need to learn about how this works, right? Like, what is under the hood? How do you train a neural network? And the answer is it's some type of gradient descent algorithm. So you don't need to know about that, right? It's just the name of it, and I'm gonna explain what it is. Gradient descent algorithm. So basically, what it is the way to train the neurons in the neural network. So this is going to be trained here, and it's going to make it better based on the data. Right? It's some type of algorithm. It's a mathematical optimization algorithm that is going to do that, right? And so people are explaining, basically, usually that's the conventional approach to learning about neural network. It's about learning how a gradient descent works, right? So the problem with that is, well, if you have a car, like let's take a car here. There you go. So if you have a car, do you actually need to know how the engine works here in order to be able to drive the car? Or do you just need to learn how to drive the car? And obviously you don't need to be an engineer and know how the engine works in order to drive the car. So when you have a neural network, it's the exact same thing. You don't need to know how the gradient descent is set up in order to train the neural network. You just need to know how to set up the neural network, not how to implement the gradient descent algorithm, which already works, right? There are a lot of people that are a lot smarter than me or you, and that have worked on this problem for a long time. And so you have tools that are readily available for using those type of thing for training a neural network. So you do not need to know about that. In fact, you're going to waste time not learning about how to drive the car here. So, not learning about how to use and train an AI or a neural network. So, there might be a few mathematical things like matrices that you're going to have to learn about, but it's like 99% of things you don't need to learn about. So, trying to learn preemptively things that are not going to be useful, like the gradient descent, this is completely counterproductive, because like if we talk about the gradient descent, what you need to learn about to be able to understand and implement that is, well, what an optimization algorithm is, what a derivative of a function is, what a derivative of vectors are, and matrices are. So and that's very, very heavy to learn about those types of things. And it's when you don't actually need to, when you already have the tool readily available, it's completely counterproductive to do that. Now, maybe if down the line you want to optimize the gradient descent for a very specific use case that you have, because you have a need to, I don't know, like you want to embed that, you want to do some type of embedded software, and because that embedded software needs specific CPU usage, you are not allowed to train it in using the regular tools that you can use right out of the box. Then sure, you're going to need to tweak some type of things in the gradient descent, but it's not going to be, you're not going to be in that use case in 99% of the time. So why would you preemptively use your time to learn about those things? So what should you do instead? And I'm going to tell you something that is, it might feel dumb, but like fun, something fun is actually better than something theoretical and nerdy. Because at least you're going to be motivated to like do it. You're going to want to learn about it. It's going to be interesting for you. And then this is going to be way better than doing something that is completely, uninteresting and nerdy, right? That is better, I would argue, than anything that you could do that is related to math or theory. Something practical, obviously, which means like something that is going to optimize your time, is going to make it a lot better also, because it's useful. You're actually going to apply it to your own life, right? If you build some type of AI that is going to optimize your life and help you save time to do tasks that you're doing at your work or whatever the thing might be, then it's going to be a lot more interesting to build that type of AI. You're going to be a lot more motivated to do that than if you were to learn about gradient descent, for example. Something else that you might be thinking about is creating an app, for example. That would be way better than anything nerdy that you could learn about, or learning about gradient descent, because an app is actually going to be, you're going to learn how to set up something that is actually going to be useful. Because setting up an app, it could be for like actual solving other people's problem, and then you could sell it, right? Or you could use it for yourself. It could be your own tool, right? So learning how to set up an app is actually going to be useful, and that's also another category of fun, because some people likes to build an app. That's actually fun to move forward and create some type of project that is going to do something that is kind of impressive, to have like an app that is working on your desktop or that is available from anywhere on the internet, right? Another thing you can work on is tools for yourself, AI tools that you build for you that are going to reduce frictions in your own work or in your own life, or again save time, or that is going to make things easier and much more enjoyable. Because like there are tons of repetitive stuff that you don't need to learn about, that you don't need to actually do, and that you should there should be AIs that do that for you, right? But those tools are not necessarily working right now. They don't exist yet, right? And they're probably going to exist, but the thing is, when this is a specific problem that you have, Well, it's usually not a difficult thing to build for yourself, because this is, you already know exactly what the problem that you want to solve is. So if you want to do that, then you can get started right away. Like, this is something that you can start with when you don't know anything about AI and you want to get started. Another issue with the academical approach is that learning about things that have already been solved in the past is not useful anymore. Why? Because everything that is learned, everything that has been solved is today standardized, right? And most people can actually, like, you can look up the answer. You don't have to learn how that works. Meaning, like, for example, now we are at the age of AI, meaning that you can ask an AI to do all of those things for you, because AIs have been trained on standardized problems, right? You're not going to make any money solving a problem that already exists. So that means you don't need to learn about those problems and how to solve them. You need to solve new problems that you have, or new problems that other people have, but learning things that have already been solved in the past is not useful anymore. So what you need is a practical way to get started. So practical. And let me emphasize that, because that's really the point, right? You need to start with an actual project or something to actually do for you, so that is going to be motivating and that you are going to actually like. Now, what's the problem though with this approach? It might feel a little bit overwhelming when you don't know anything about AI and get started with the project right away, right? So that's the reason why I created your complete roadmap to creating your own AI today. You can click on the link in the description to get started. In this course, you'll get my personal framework to get started and build your own AI. You'll know exactly what to do when you are non-technical and you don't have a mathematical or programming background. I also create an AI in front of you directly using a large language model, so that you can actually know how easy it is to get started with AI. Thank you for watching, and see you in the next one.